said. All right, we're looking at how to solve the Unit 6 assignment by first looking at the sample file that was provided for the tennis data, right, to build a decision tree. I'm running this inside of Visual Studio Code because I've been having problems with Jupyter Notebook, where it does this really crazy like stutter effect on the screen, and I find it unworkable. Fortunately, I have this environment set up to work. The primary difference about working here versus working in the Jupyter Notebook is Visual Studio Code, by its own prompting, advises that I create a separate virtual kernel of Python. So it duplicates the Python kernel within its own environment. And therefore, it's kind of like a blank Python install. And therefore, when I'm needing to load up all the libraries here, that's like the first major code cell for most of you, it's not working. And therefore, I'm running these pip commands inside here. This was by the urging of the Copilot chat tool that's inside of Visual Studio Code. Just recommended, you could virtualize the kernel, install the stuff, and then come back and run it and it'll work. Or you can just run these pip commands every time and whatever. So that's what I decided to do. So I'm going to run this and I'm triggering it to run. And notice it's having me choose my virtual environment. That's the VENV stands for, right? And so now it's connecting to that kernel and now it's running it. The last time I ran this command, I think it took 4 minutes to run it. And I don't know if that was because of how my system was stuck, but what it is doing is it's kind of like doing an install of each one of these libraries, all the dependencies, including going out to the internet, downloading them, decompressing them, installing them. And sometimes when you install one library, it installs 5 or 6 or 8 others. So this might be installing like 50 different things right now. I'm going to let it do its thing, but I'm just putting it out there that this is something that you can do internally, even in Jupyter Notebook if stuff's not working, right? So I guess I'm calling it kind of a Band-Aid fix. Now, if you are running Anaconda, Anaconda has those environment variables on a tab, and most of this stuff is actually pre-installed. Pandas, NumPy, scikit-learn, Plotly, Matplotlib, those are all pre-installed in Anaconda if you get the full distribution. GraphViz, I think was pre-installed. I'm not 100% sure, but maybe I did have to add that one. My memory is failing me right now, even though it was just like 2 hours ago, whatever. The second pip command that you see here is basically going to do a confirmation that everything was installed, and we're just going to let it like do its thing. So it's iterating right now. Like I said, last time it took 4 minutes. I don't know if I have 4 minutes of talking within me right now, but let's just take it on faith that it's working. Okay, so the last time I ran this, so I did the solution here, and I'm looking at the wrong solution. That's not the one I want to look at. I want to look at this one. So this is the one that I managed to successfully run earlier. So I'm not going to need to re-execute all the steps. So those of you that are looking for solutions here, screenshot away. But I ran those same pip commands. After they were finished running, I got this confirmation, which is similar to what you see on a command prompt if you run them manually. And it verified that they were all installed and what version was there. I do want you to notice that GraphViz didn't list here, even though it was part of the install. All right, so this is one of the anomalies. Then I went ahead, I ran the import cell, that worked just fine. Ran all the imports, found them all, and then it went into, I want you to notice this is the first change, significant change in the code, where we're attaching the fitbit data file. So instead of it saying tennis CSV, I downloaded the CSV file that I provided. And notice that it loaded it, it read the CSV file, put it into a data frame, output the first 5 and the last 5 rows is what it did. Right. And here you can see the data points. And part of what we were talking about earlier during lecture is the Fitbit data, similar to the tennis data, but it's got more features, right? So heart rate, steps, sleep hours, calories, and stress level, and those are all numeric quantitative values. And then we have health status, which is a qualitative measure that's based upon the others, right? And we need something like that. So this would be our labeled data for this data set in order for it to be targeting it as an output. Like we want people to be healthy, right? So that's kind of like a target in a sense. But we're also looking at the data points that trigger it to be one thing or the other. All right. There are questions in here, and you'll notice that the questions, I revised my answers to the questions based upon that. I hope you guys do the same. I know some of you will skip over this, but you should ideally, because it's asking the same questions on a different set of data, and these are basically the answers, like what rows, what data. So we're tweaking all those answers, and yeah, there's 152 rows of data. Then we go into the label encoding part, and here's where we're, uh, we're picking a column, like which is the column that's kind of our target. And this is what I was mentioning before. And we're really trying to transform the data to fit the health status, right? And then you can notice that that is being converted now to numeric values for processing. That's one of the parts of it. We then take the data set that we're provided and we split it. And once again, we indicate in the data frame what data we're working with. And then we have to determine a split point. So the test size is 20%. That's what this number means, meaning our training data is 80%. That number can be adjusted. If you think that training is better at 70% or 73.5 or whatever, whatever that is, you can determine that there. Right. So we just left this one alone. There was really not a reason to change it in my mind. Right. Then we do an output of the data. So in other words, we take a look at what some of the data is and notice how all of these values, these are the health status numbers that are all put in basically an integer array. Right, and that's the kind of the output value. We also look at the training data, then we look at the testing data, right? And notice this one excludes, at least in the top part of the chart here, the health statuses, but once again in the array at the bottom. Then we get into the model aspect, and there's not really a lot of changes here, if you're comparing between the codes. There was a couple of spots, and I don't know if you guys found these too when I was running the code. I found one piece of code that was deprecated, which I fixed. All right, so this is the modeling approach that we're using. So we are, saying that we're using the decision tree, right? We're looking for the data to fit, and comparing the training data to the test data. Right, so that's pretty straight ahead. Here, though, we need to figure out when we have to set some properties for the tree. And did many of you tweak this portion? Like anybody who got it to work? How much tweaking did you do here? Nobody? Did anybody change this section at all? Because there is one spot where I had to change it. And I don't know if you ran into this, but I did. Here, this particular part that I just highlighted, the in underscore, the old version of the command was just n features, and I ran it and it gave me an error message and said, oh, that's the old version. It's deprecated. You got to fix it. So I did that. And basically I let the AI do it. So the correct command here on the fourth line is n features in with underscores before and after. And once I made that tweak, it works just fine, right? And so that's one of those spots where you maybe got stuck and then you ask the AI. And that's what I like also about the Visual Studio Code is I can just turn on the AI agent here and it's ready to go, you know. And then it can also, depending on which mode you're in Visual Studio, you can, and in agent mode in particular, it can inject the code back in and fix it for you and show you what it fixed, right? Both scary and kind of cool at the same time. All right, moving on from there, we start to evaluate basically the fit of the training data. There shouldn't really be a lot of change to the code here. And then it says accuracy score 1.0. So is that good or bad? Yeah. That's good. It is good. Correct. Then we did evaluation on the testing data. And notice the accuracy score here. Not quite a 1.0, but pretty high, meaning that our test data worked out pretty well also, right? That's generally what it means, right? You can think of it as a 90%, I guess. But that's a pretty high number. That's pretty accurate. And then once again, answers to the questions. And I don't know if I revised that one at all. And then we did the visualization of the tree. Now I'm going to show you the tree and the aftermath kind of all at once. But there were maybe a couple little tweaks to do here, but because the real tweaks were the data file that we fed in, and then the change in the deprecated code. Those are really the main two changes. You guys, did anybody make any significantly larger changes to their code? No, I don't. You shouldn't be, right? All right. So I ran this code, which was also given to us, and for me, it generated this decision tree. Now I'm going to zoom out so we can get it all on the screen at the same time, if I can. I'm trying. There we go. Something like that. And I know some of you, when you did this output, you took the graphic and it was really wide. But this decision tree, once again, remember the algorithm, right? It finds the lowest Gini number, right? And what's that one at the top? And then it kind of branches down from there. But according to the scenario, this should help you determine whether something is healthy or unhealthy if you go all the way down through this tree and all the output paths. Now remember, any of the purple cells here are the leaves, right? This is our root node. These are the intermediate nodes. And the ones that terminate at an end are what we call the leaf nodes, or the result path. Now, this is one solution. So I just put it out there as that, right? And if you wanted to compare this to your solution, I'll very slowly scroll through it. So like if you're watching the video in the aftermath, you can do a comparison. All right, so this is second part. Moving on to the third part. Moving on to the final part. Right, and that's just so you can do a screenshot, compare, whatever. All right. Now, I don't know if this code ever finished. It took 3 minutes this time, a little bit faster than last time, but I'm just going to go ahead and save that one. That's my starter example, and this is my official solution. Now, interestingly, and I usually obscure this from my students, is sometimes in my course shells when I come up with solutions to stuff, I leave traces of the stuff for instructors, so that like if somebody else teaches the course and they've never done it, they have all the answers, that kind of thing. Just being courteous, basically, also to myself. And I did task an AI to take the same question. I gave it the Fitbit data, and then I asked it to create a decision tree based on that data, right? Just cold, without using the example that we had. And what it did is it created a different output. And I'm downloading it right now. Actually, I have this on my system. This is kind of silly. I'm doing it this way, but I'm going to go ahead and load it up into Visual Studio Code here, and we'll just take a look at it. So this is code that was generated by, I think it was either GPT or Claude. It was one of the two, and I'm thinking it was Chat GPT. That's been a week or two. I have it written down somewhere. Anyhow, um, but I just wanted you to notice the different approach it used. Okay, so the one thing that it did is it did include all the same libraries, right? Um, it generated its own synthetic data. All right, so this is kind of weird. I didn't ask it to do this, but I'm like, all right, whatever, that's fine, right? Um, you can feed in my data file, or you can generate your own. Right, that's an algorithm. So it actually did the generation of the random stuff, which was fine. And then ultimately, the first time I ran this, it's that synthetic data I used to provide for you guys. Right. So every time you would run this, you would get a different set of synthetic data, by the way. And whether or not it's accurate to a real human being is a whole separate thing. Once again, once we have the data, we load it up into a data frame. And then it's exported to that file. So that's how we got the file. And then we start to train it. Once again, we're still using kind of that same test size that's fairly standard. And then notice here, we also put in some parameters that maybe we didn't use before, which is we decided to put a max depth on it. In other words, I don't want this thing going 20 layers down in my decision tree. Now, I did not choose that arbitrary number. The AI model chose it for some reason. Interesting, right? And then the random state of 42. We went through and we visualized it, and then that did create the graph, and we evaluated the output of it. So this does not show the output in it, but the output I do have embedded into the core shell here. So this is the image it generated. And I want you to notice that when you bring it down to 4 levels, right? So that's a parameter you guys could add to. It's really a much more manageable decision tree. But in principle, still covers all the same decision paths. Whether or not this model fits well or not, well, that depends on the evaluation. So if you go through and you run the code, you can run the evaluation on the model and see how well the data fits. So the model that we had, right, with the test data reached a 90. I wonder what this one would reach. So that I would challenge you. Now, I'm not going to provide you the code files for this, right? You'll have to capture the code from the screenshots if you want to try to recreate it and whatever. But it is out there. I mean, it's not that hard to do. And I can give you a hint as well. And I think I demonstrated this during class. You can take images, feed them to an AI engine and say, OCR the information in here to extract all the code. So you could screenshot my code, tell it to OCR it, and convert it to code and try to run it. You know, if you don't want to type it in, it might be just as easy to type it in. I'm just putting it out there, right? I did see, yeah, Finley, I see your comment there, 42, correct. That's the magic number of the universe. But I did see that some people came up with even different solutions, and some people went way above and beyond on this one and really kind of pushed the limits of it. Does anybody have a solution that they might want to share here or talk about how their solution was different? The other thing that we can entertain here, well, is if there were issues, how those issues were solved. I don't want to record all that stuff into the video, so I am going to terminate the video here. But let's have a talk about